Welcome! In this session, we will learn to run a logistic regression. This type of regression is useful when the dependent variable is categorical. Although we are clear that this is a neural networks course, the objective of running a logistic regression is to compare the precision of the models and also highlight some advantages and limitations of neural networks. So we are here in R, and we are going to create our model of logistic regression. So we are going to create the variable model2, which equals to the function glm, and this function will have three parameters. The first of them will be the formula of the regression. So we have the dependent variable is defaulter flag, and defaulter flag equals to alt 126 to all the variables in the dataset. When I put that period, I'm telling R use all the variables of the dataset less than the dependent variable and also less than the other dependent variable that we are not using, which is defaulter type. Comma, shift enter, so I go to the other line. Then I'm going to tell R that this is a logistic regression. So I'm going to tell the family of this regression is binomial, zeros and one, or just two categories. And I want you to use a logistic regression. That is logic. Actually, is this one that is suggesting logic. This one. Okay. Then I press a comma, shift enter, so I go to the other line, and I'm going to tell R that I want it to use the dataset training. So we are ready to run our logistic regression. I press enter. And it has done the regression. We can look at it at model 2. We have it here. Model 2, a list of 30 elements. And we are going to summarize this regression, the summary of model 2. With these results, we still cannot compare the precision of the models, but we can observe a limitation of the neural networks, and that is that we cannot interpret the results. They are a black box. On the contrary, we can draw some conclusions from the coefficients of the logistic regressions. Firstly, we can see that almost all the independent variables are statistically significant. Almost all of them have the 3 or 2 stars. The only one that is not statistically significant is the monthly income. As you can see here, it doesn't have the 3 stars. Secondly, and perhaps more importantly, we can interpret some of the results with the signs of the coefficients. For example, we can observe that the older the age, it has a negative coefficient, and also the higher the down payment fraction, the down payment as a fraction of the total credit, they increase the probability or decrease the probability of falling into default. As you can see, they have negative coefficient. On the other hand, having a washing machine and a fridge, which are proxies of the person lifestyles and perhaps the customer solvency, their capacity for repaying the credit, and also having signed the full post-data checks, you can see here, they also reduce the probability of defaulting. These three variables have negative coefficient, as you can see. On the other hand, and now I can talk on the other hand because I will talk about one that has positive coefficient. Having a higher number of dependents increases the probability of falling into default. As you can see in this variable, the number of dependents has a positive coefficient. And probably the things that I have already said may be very intuitive conclusions, and we did not need a regression analysis to determine them, but they could confirm, or the regression analysis could confirm and give statistically support to managerial decisions regarding credit policies. It would have been very difficult to obtain these insights with neural networks, because in that case you cannot interpret the coefficients, despite the predictive power of the neural networks. In the next session, we will estimate the precision of the logistic regression model to compare it with that of the neural networks. Thanks for watching.